Hey everyone, Morgan here, continuing on talking about solutions, and we're getting deeper and deeper into this. And today we're talking about something called colligative properties. Now the word colligative comes from a root colligare, which means to bind together or to hold together. And it is actually the source of the name for Colgate toothpaste. It helps keep your teeth together. So, what is a colligative property? It is any property of a solution that depends upon the relative number of solute particles. Just the number of them that are there, not what they are. Okay? Now there are 4 colligative properties. We talked about one in the last lecture. It was called vapor pressure lowering. We showed how when you put a solute into water, it decreases the number of water molecules that are going to escape the liquid phase into the vapor phase at a given temperature. There's also one called boiling point elevation. One called freezing point depression. Freezing point depression. And finally, one you might have learned about in biology called osmotic pressure. Okay, so picture an ideal solution. You have a non-volatile, non-electrolyte, and you put them together, okay? We have solute and solvent. The vapor pressure will go down. It's page 8 of this outline. Now, there is an equation that governs this. The change in the vapor pressure equals the mole fraction of B times the vapor pressure of pure component A. That is derivable if you like doing algebra. I just don't think we need to talk about it that much. Now, let's see what this looks like on a phase diagram. So here's your classic phase diagram for water, where you have the solid, the liquid, and the gas. Now, if we were to change the freezing points or the boiling points, what would happen is that this area that is the liquid region on the phase diagram would change. And this amount would be delta T boiling, and this amount would be delta T freezing. Okay? So, we can change vapor pressures, but we can also change boiling points and freezing points. How does this work? Well, if I'm adding solute, it's going to require a higher temperature to bring the liquid to boiling. So you got to remember, the boiling point is where the vapor pressure of the liquid is equal to the vapor pressure applied to it, the applied pressure. Okay? Now, freezing. It's a little more complicated. You get the particles in between the water molecules. Now, for that to go into the solid phase, it means that the particles have to be moving even slower for the attractive forces to get in there. So if I have a water molecule and I bring another one over it, next to it, boom, they attach. If I move it too fast, it doesn't happen. But they have to be moving even slower now because I've got other particles in play that might have an attractive force. Okay? Oh, they got to be moving really slow for that to happen this time. Okay? Now, ideally, 1 mole of any non-volatile, non-electrolytic solute in a given amount of solvent will have the same effect on the colligative properties as any other. That's because this just depends upon the relative number of particles. I have to say non-electrolytic because I don't want them dissociating. That changes the number of particles. We'll deal with that on a later page. We don't want them to be volatile because that would have an effect also. So, delta T freezing would equal Kf times the molality. Delta T boil equal Kb times the molality, where Kf is the freezing point depression constant and Kb is the boiling point elevation constant. Now, they're provided here for water. You don't memorize these things. These are always provided in questions. It's different for each solvent. Okay? Now, molality. Because molarity is temperature dependent. So I need molality because it does not depend upon temperature. And that's the big reason that we had you studying molality, okay, in this chapter. All right, let's look at some everyday examples that you might be familiar with. Now, when you're cooking noodles, often you will add salt. This is not for flavoring. As much as you might think it is, it's not to flavor the water. This is water soluble. When you dump off the water from the noodles, the salt leaves with it. You put it in there because it raises the boiling point of the water. Now, that means the water's boiling at a higher temperature and it's going to cook faster because it's up there at that higher temperature. Okay? Raises the boiling point. Cooks faster. Now, not in California, but for any of you who've been somewhere else, you understand about salting highways after a snowstorm. Or actually, it's best to do it right before it. When the snow hits the salt, we have the possibility for hydration. And you go back a few pages where we talked about, formation of a solution. You see that if step 3 of that formation, like it is for the salts they use here, which mostly they use calcium chloride, okay? That releases heat. So when it releases the heat, it causes the snow on the highway to melt. Now, it's a solution. It's salt water, it's not pure water now. And its freezing point is lower, so it's less likely to refreeze. And I hate sidewalks and roads where the snow has melted and then refrozen because it just turns into very slick ice and you're very likely to fall. Now, I've had some nephews living out in colder climates who their winter job is going around and shoveling the snow and salting the sidewalks around all of their neighbors' houses. Okay? So it's a good way of picking up money on the side. Now, some of you might be familiar with this, actually from the use of an ice cream machine, an ice cream maker. You'll have an inner container that contains the ice cream mixture. We drop that into a big container that we fill with ice. Then what you do is you put salt, rock salt typically, on top of the ice. No, not in the ice cream. That would be nice, nasty. Ugh, nasty. And it causes that ice to melt and to go down to a lower temperature. so that the ice cream actually forms up. Now here in California, we understand it because of the concept of antifreeze, which is also anti-boil in a car's radiator. Because you don't want the water in a radiator to freeze. That would crack it. And you don't want it to boil because it could explode. So you put in antifreeze, which means it has to be even hotter or even colder for it to boil or to freeze. And there's brands like Prestone and things like that that they use for it. Usually it's ethylene glycol. Okay, so that's a little bit about what a colligative property is. In our next lecture, we'll come back and we will look at these mathematically. All right, thanks for tuning in. This is Morgan signing off.